Hello students, let us try to understand the enthalpy of bond dissociation. In another word, it is also known as bond dissociation enthalpy. So let us try to understand students what is meaning of bond dissociation enthalpy. The amount of energy required to break a particular bond in a given compound and to separate the resulting gaseous atom or ion or radical in bond is called the bond dissociation energy. Okay. So again, what I am saying, bond dissociation energy is required to break 1 mole of the bond. The amount of energy required to break 1 mole of particular bond, 1 mole of particular bond in a given compound, and to separate the resulting gaseous atom or ion or radicals is called bond dissociation energy. For example, they have given the H2 is there and bond dissociation of H2 is at 435.9 kilojoule per mole. So that is 1 mole, the energy required to break the 1 mole of bond, single bond is 435.4 kilojoule. For diatomic molecule, bond dissociation energy equal to bond energy. Okay. And polyatomic molecule, each bond has the dissociation energy, different dissociation energy. No, bond dissociation energy and bond energy are applicable only in the gaseous phase. In a liquid phase, we have to neglect that. Okay, and next one, what the next point they are saying, the bond energy in polyatomic molecule, the important term, the bond energy in polyatomic molecule will be only average value. It will be only average value because in each step of the dissociation, different fragments are involved. Okay, now CH4 is converting to CH3 plus H. Here dissociation energy 427. CH3 is converting to CH2, again given H, it is 418. CH2 is converting CH, giving H, it is 460. And CH is converting C and H, it is 343.1 kilojoule. So CH4 plus giving rise C plus 4H, its total bond dissociation energy is 1648.7 kilojoule per mole. Okay, that is also that is enthalpy of atomization of CH4. So how we can write, the 4 CH bond is there, 4 CH bond is there, so equal to bond dissociation energy. So 4 CH bond, each bond if you are calculating, that is 412.2 kilojoule per mole. Okay, next point, average bond dissociation energy, heat of dissociation of substance by number of covalent bond broken. So like that, okay, we can get the bond dissociation energy. Here are the tables are there, student. In the bond dissociation energy, how we have to calculate. Note that symbol used for the dissociation enthalpy means bond enthalpy is same. If we use enthalpy of bond formation, if you use the enthalpy of bond formation, that is delta FH not bond, which is the enthalpy change when 1 mole of particular type of bond is formed from the gaseous atom. So in that case, enthalpy of formation, that is bond of product minus bond of reactant. This is what the enthalpy of bond formation. Okay, and so this is what are their value. What are the another? What do you mean by term bond enthalpy? So bond enthalpy, which is also known as bond dissociation enthalpy, average bond energy or bond strength, describe the amount of energy stored in a bond between atoms in a molecule. Specifically, it's the energy that needs to be added for the homolytic or symmetrical cleavage of the bond in the gas phase. Next one is there, what is the bond enthalpy? Positive, is bond enthalpy positive or negative? By definition, bond enthalpy is the energy put in to break a bond. Hence, the endothermic and always a positive number. The reaction enthalpy can be negative exothermic or positive endothermic because bond is broken in the reactant and bond is formed in the product. So that is, it can be positive or negative both. Next one, what is the bond enthalpy and product are values used? The bond enthalpy is the energy needed to break a bond in the chemical compound in the gaseous state, and bond enthalpy value can be used to calculate the enthalpy change of the reaction. The sign of the enthalpy change of the reaction indicate energy is absorbed endothermic, energy release exothermic in a chemical reaction. Next, the mean bond enthalpy is the enthalpy change needed to break the covalent bond into gaseous atom, average over the different molecule. These values are positive because energy is required to break a bond. The definition only applies when the substance start and end in the gaseous state. So this is what the meaning of bond dissociation enthalpy is, student. That is a very simple term. We have to keep in mind that how we have to calculate the bond dissociation enthalpy. Okay, let us solve the sum of the problem on the basis of bond dissociation enthalpy, students.